So at the beginning of this week, I was publishing a result that I did with a RangeVision turntable scanner. That was a RangeVision Spectrum, where I tested the penetration depth in small holes or gaps with the scanner, and I got to say, it was astonishing to me, but the people who saw the results, they were really celebrating it. So looking at the results that was created with a hand scanner, I can see compared to the one that I did on the turntable that there is not the same depth of penetration in the scan. It's quite good for a hand scanner, but you see down there is already quite some areas that wasn't captured as this was merged watertight. It's not as easy to see the borders as well. The outlet window wasn't captured entirely. There was some points missing in the middle where there was shadowing. For the geometry, the same on the boost port, but this could have maybe been captured better because the other side was possible. But this is already a scan that took quite some time and was the maximum that was possible. With the hand scanner, there was, let's say, a lot of different views into the different holes, rotating around the screw holes, each of them. So it was a more, let's say, time-consuming scan, and then even the one on the turntable, just to see how far you can get. And you see that the results on the surface are quite fine, but if you're taking a look into the deeper areas of the cooling body and so on, as well the screw holes, they don't have the same quality. So, but of course, compared to the master of all scan possibilities, in that case that would be the CT scan, all of this is quite incomplete. Looking at the CT results, you will fastly realize that there is nothing missing, that there is no undefined areas, that there is even all the inside of the cooling pockets in that cast totally replicated. So if you are, let's say, capable of paying 500 euros more or less for a scan, of course this gives you the best result, but compared to RangeVision scanner, this is already nearly 10% of the buying price of the whole scanner, and therefore you got to think twice if you are able to pay that many times. Of course, if you have a highly dotated project, you can go for CT scanning and you will have a good result, but maybe you don't have to. So what does make the difference? Here we can see a sketch from a hand scanner projected from the side, and you can see that there is an angle between the light source and the camera itself. And if you think about the light beam that's emitted from the light source, that's in this case a projector, coming to the surface is being reflected and absorbed by the camera. There is a problem if in that ray send it to the surface or on the way back to the camera is some interruption that will cause a missing image. So all that systems using a triangulation for depth measuring and even photogrammetry is using it. They have a limited, let's say, minimum angle where you are able to generate a depth information, and this is here in hand scanners a bit bigger, like in most of the projection scanners. If you are taking a look, for example, from the top of that RangeVision Spectrum, you can see that here is that angle more or less 15 degrees. That is a really narrow setup. That means you are like working with a tool, having a quite sharp knife with a small tip that enters in a lot of areas, and that's actually what's happening here as well. It's quite comparable. And so if you want to enter into deep, let's say, spaces, small angles between emission source, it can be laser or any kind of the light source, and the camera is favorable. So why don't all the producers go that way? That's quite easy to explain. It's because you are losing preciseness in the calculation of depth of field. So you can gain preciseness by simple angular functions, by creating a bigger angle, but you will lose penetration into small gaps as a result. So most of the scanning systems using angles between 10 to 25, 30 degrees between light source and camera. This is quite most of the times a range that will be kept. So without entering too deep into the theory of the calculation of depth points, we are going to start with an application example to show you a very practical realization of a scan of deep holes, and you can see how it is done, and it's actually not too complicated. So what becomes important is that you are in the rotation of the turntable, are able to see all the areas that you want to scan, and therefore you will have to use several different angles for your scan head, and I'm just demonstrating you the way how you should adjust it. So for example, in this angle I want to scan the inside of the transfer ports on the runway side, and as well I want to scan as much as possible to the inside of the transfer port inlet into the cylinder itself from the crankcase coming. And I always try that areas that are in focus to see them from both cameras. So you have here a left and right camera on the two windows, and if I turn the turntable manually or the position and I'm interested in some special areas, I'm always considering seeing them in both cameras, so you can be sure that they will be captured fine. So this is some intermediate angle that will capture not, for example, the whole area. I can sketch that into the inside of this channel. There will be some rests not captured, but I will meanwhile capture on the runway side these areas, and this is some intermediate angle. So for example, if I want to capture inside that cylinder transfer ports in the maximum depth, I will have to adjust the scan head and try to look as much as possible into the deep areas of the transfer ports. For example, like this. I'm in this case seeing both of that areas in the transfer ports, deepest areas, as much as possible. So what matters is that I see as deep as possible into the areas of the ground from the transfer ports. That would be the next angle. And I can do that even more radical. That means scanning 90 degrees from above. Sometimes it's enough if you find a good intermediate angle that captures, let's say, not at 90 degrees, but most of it from one side. You have to try it a little bit. You will see that by the ring results that you will capture. So for capturing that inside of that cylinder and the transfer ports, it was enough to capture it from two different radical angles when the cylinder was turned upside down. And I did another one from the turned around position. So when I turned the cylinder in the upright position, I was scanning from some intermediate angle into the cylinder to capture as well the windows from the different parts. And beside that, I did two simple outside angles on the surface of the cylinder. And that's all actually. There wasn't needed more. I just did one special orientation into the outlets channel. The outlet channel is really, let's say, more difficult to scan. It is quite deep. And I used one orientation where I was rotating more or less the intermediate axis through that outlet channel. So I was able to scan inside the outlet channel as much as possible, orientating the camera in the same rules that I showed before. And that's it actually. So in the amount of time I am calculating for each of that rings, and one ring is one 360-degree turning scans. I calculate about 5 to 10 minutes. I think it's 5 minutes. I can measure that if it's interesting, but it is not really something you consider because you are merging automatically. You don't even have to care about that. So you are just putting that cylinder in the right orientation, start to scan, and meanwhile you can read your emails or do something else, reposition, restart your scan, get yourself a cup of coffee, and continue. So it's something, having your scanner beside your desk, it's something really comfortable to create that scans while working something totally different. So I gotta say the comfort factor is compared to a hand scanner even higher, even if the hand scanner can shoot the frames faster than a desktop scanner, but in the end that speed doesn't help you because of the limited penetration into deep holes, and you will end up having a better result anyway using your portable scanner on the desktop. So compared to all other laser scanner based results that I created from this special part, where you are absolutely able to test your penetration ability into small holes and gaps, this is really outstanding. This is a really good result because of the small camera angle from the RangeVision spectrum to the light source. That means angle between projector and cameras. You have a really good penetration of, here for example, the transfer ports. You are able to entirely scan the running area of the two-stroke engine, so that is not too far away from the results that I did based on a CT scanner that was of course more complete. And that's amazing. I have here really the transfer ports edges entirely and exhaust port edges. I could even make a timing sheet based on that scan, and that's for an optical scan without using any kind of plastilene mask for getting the inside shapes. It's really astonishing. I was even able to scan quite well into that outlet port. I think I could have gone further if I wouldn't have had that coal residuals on the wall of the outlet from burning. I tried to spray it with Azob, but because of its oily surface, it wasn't covering that well, and I wasn't, let's say, owning this part at that time, so I was, let's say, not want to start to scratch inside the outlet because of that scan. It was generally it was a good part in good shape. So let's see how good will be the comparison regarding preciseness, but the result overall is overwhelming. I will export that mesh into Geomagic Essentials to fill up the holes that I think that they are not so bad. Doing this in RangeVision software, that filling up of holes, curvature based and so on, wasn't working so fine in the last result, but so far this is an amazing result in good resolution and a high degree of reached areas regarding the scan in gaps. So here in this case I'm going to close the holes that have a standard size and not are too complex by an automatic all fill holes command that I limit by the length of the hole borders, so you are able to select which of them will be filled automatically and which not. And with this command I just get rid of all that let's say small stuff that I need not to correct. Holes that are very small and surrounded by good surfaces are not necessarily a problem regarding loss of information, because curvature based filling will create a surface information that's nearly the same like if you would have scanned it perfectly. So here we have some bigger holes that are on the back side of the transfer parts, where light, by the fact that it cannot make its way around the corner, at least in standard situations, cannot scan it with no optical scanners. These are the areas, and I'm just going to fill them up by holes fill command, and I'm using curvature based filling algorithms. That means there will be a curvature, let's say, constancy in second degree. That means if you would take a polynomial that will, by a curve, go over the border that you create by the filling, it will be steady till a polynomial degree of 2. So this replicates quite well the intentional areas that have been there in the design. So the deviation between design and scan will not be too big. And by filling up the holes, you will still keep it. There is some upper area for that outlet power valve system where it's just as well the same problem. There is like a really big shape inside that is not reachable by light because there was a lost sand core in there by the production, so it has backdrafts and you will not be able to perfectly scan that with optics, but no problem, we can live with this. And same on the all other transfer ports. There is the backsides that are not totally scannable. Okay. So let's take a look if there is major areas not filled. And afterwards we can conclude that mesh resolved by just closing the holes fill command. And that's it. So here we have right now a really quality scan that's just an optical scan that is nearly in the condition of a CT scan. And this with a scanner that ranges in the price of 5,000 euros. I think this is really a really good result.